Software 2.0 using AI with Aaron Stannard.
The AI Devops podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that AI and Azure and the .NET ecosystem has to offer. I have a return guest on the show back from episode 172, Aaron Stannard, and he is the founder and CEO of Petabridge and the co-founder and lead maintainer of Akka.net, which is the most widely used actor model framework for .NET, over 21 million NuGet downloads, and has adoption by Fortune 500 companies like Boeing, Bank of America, S&P Global, just some of the other ones that I've seen. He's a two-time startup founder, and Aaron has previously founded MarkedUp Analytics, and he's worked at Microsoft as a Startup Developer Evangelist before dedicating himself full-time to building the Akka.net ecosystem. He's a Vanderbilt University graduate, a former Microsoft MVP. He's spoken at major conferences worldwide, including the Norwegian Developer Conference, Techorama, QCon, and .NET Conf, and many, many others. And beyond Akka.net, Aaron is known for creating NBench, which is a .NET performance benchmarking framework, and the Sdkbin marketplace for .NET developers, so many things. And he's also known for his prolific blog and YouTube content on distributed systems and .NET internals and other things, including software engineering philosophy. So excited to have Aaron back to the show. How are you, sir?
Busy, but good. Lots to do all the time with how quickly things are kind of evolving in our industry right now, but I'm enjoying doing it and, getting a chance to kind of get my fingers into a lot of different little projects here and there. I think the hardest part for me has actually been sitting down and writing down about the stuff I'm doing. Like those Software 2.0 content you mentioned in the title there, each one of those posts took me probably, 10, 12 hours to go ahead and put all that together. And it's like, I kind of have to go back through my commit history and some of the repositories and find old prompts that I used and other planning artifacts for using AI to build some of these projects. And I'm trying to kind of reverse engineer that so I can explain how to do it again, And so that's probably been the thing I've had the most difficulty doing is I've been trying so many different little experiments as far as using AI to help manage our business, Petabridge, and develop new products and help us maintain some of our open source technology. And, I've also gotten my employees Quad Code subscriptions and all that. And it's, teaching them how to do it too. So there's kind of a lot going on everywhere all at once. And sure, you feel the same way with your business too.
Yeah. Well, I want to ask you about all that, but I like to just ask the guests to go back in time a little bit. And you've had a multi-decade career now in software engineering and computer code in general, getting computers to do interesting things. And now seeing this industry is kind of remaking itself yet again. What is it about computer science and software engineering that just keeps you engaged and motivated and jazzed up about the profession?
There were a lot of problems that no one made the time to fix because the overhead of doing it was just so big. What AI has done has shrunk the opportunity cost for going after some of those problems. And, a really simple, basic example of this is imagine the dozens of little processes that it takes to run a business every day, or even something simpler than that. I'll give you an example. I run a .NET user group, and I'm working on building an MCP server to help Claude help me synchronize what's on meetup.com with what's on our Meetup's website and what we store in Notion, where we go ahead and we internally track all this stuff, because there's not a lot of business value in having me transcribe from one of these mediums to the other two all the time, right? That's a perfectly automatable task, and there's zero chance I would have spent the time automating that versus doing the 2 hours of legwork to go ahead and kind of do that every time we have a meetup. No way I would have spent the time automating that 3 years ago. But with tools like Claude and the MCP ecosystem, that's all available now. So I think the idea that as an industry, we're basically surrendering the fun parts of software to AIs is fundamentally kind of wrong. In my line of work, I kind of have a foot in like 3 distinct forms of software engineering. I have to do the super low-level performance engineering on something like Akka.net. Like right now, for instance, I got a draft pull request open where we're trying to get system.memory primitives integrated deeply into our networking stack, which is like 10 years old, so it's in need of modernization. And then I'm also working on replacing the serialization system to use a buffer writing strategy, because that's basically offers some more mechanical sympathy for doing things like nested envelopes. And these are all like pretty high level, like low level engineering problems in terms of needing to be close to the metal. Mm-hmm. But that's like the type of taste making and sort of experimentation stuff that you can't simply hand over to an LLM, because it has no intrinsic sort of understanding of what this means from like a world point of view. They're just text prediction engines, right?
Yeah.
Now, once you come up with a design, it could certainly help you implement, test, and even improve it. That is absolutely true. But architectural and design work, which is like the second area that I've got my leg in, you can't really delegate that to an LLM very easily anyway, either. And the reason is, like, this is where 80% of all creativity in software happens, is deciding what to build and how to build it, not actually doing the coding part of it. You can't really delegate that high-level work to an LLM. You have to be able to specify in fairly grounded terms what it is you hope to achieve. And I think that's probably of all the... And then the third area is basically my diagnostic work I do, which is troubleshooting problems our paying customers have with their Akka.net applications. And LLMs are pretty good at doing a lot of work there. Helps that we're an open source project, so there's like a pretty rich corpus of literature on Stack Overflow and GitHub that it can kind of draw from. But it's pretty good at being able to navigate a lot of that. And that always has kind of been finding the needle in the haystack. And if you've got Claude running, 4 parallel agents, each power grepping through a different assembly, and even doing things like IL-spy to get down to the low-level dependencies, it can power grep a lot faster than a human ever could, And that's a really efficient place to use AI. Even a couple of years ago, it was still pretty good. But the first two, the performance engineering, and then you got the architecture and design, I think the area where developers really have not developed muscle to wield AI well is in that second area, being able to be given a blank sheet of paper and draw a castle on it. That's really where I think a lot of software engineers are going to struggle in the era of AI. You're not simply going to be handed a Jira ticket that someone else wrote anymore and be expected to shuffle it around for story points or whatever, 5 days out of the week. Now you're going to be given a lot more broad, sort of ambiguous directives, and you're going to be expected to flesh a lot more of that out and develop skills that look a lot closer to being like a PM rather than just a code monkey, essentially. And that transition will probably be very painful for some people. For others, it'll be liberating. Kind of really depends on why you got into the industry.
Yeah. Interesting. Well, you have, like I mentioned earlier, you have a pretty prolific blog at aaronstannard.com. I enjoy reading it. And one of your recent posts has been this term software 2.0, of course, kind of anchored in AI. And so now it's about 26-minute read according to your blog. But what was the thought in your head for, one, that term kind of popping in your head and then thinking, okay, I need to read about this. Yes, something's fundamentally changing, and so something 2.0. And what was the inspiration that led to you putting that out?
So it was kind of observing my own experience building TextForge, which is a SaaS service I launched completely like divorced from anything in our normal business, which was TextForge is like a little SaaS product for allowing you to safely delegate control of your inbox to like an LLM agent. I use it to automate all of my sales follow-ups, which was never an activity that required much creativity at all on my part. It was largely copying and pasting templates into emails, Pretty important that it all gets sent out because this is what gets us paid, what gets deals closed. But it was not something I particularly enjoyed training humans how to do. Not something I enjoyed doing myself, and pretty routine and now very easily automatable in the age of AI. But TextForge, went from being like a self-hosted app that I kind of did as a side project back in November of last year. And then when openclaw blew up, and nuked a bunch of people's inboxes with like unauthorized emails getting sent back and forth all over the place, I thought maybe there's a market opportunity to kind of turn this into a software as a service product. And I thought, it'll probably take me a couple months to go from what I've got now to that sort of polished product. And I'd love to just see if I could do it. That was kind of the thinking there. My expectation that this thing will make me a billionaire is zero. But I just wanted to see what I could do and how I could push LLM coding to its limits. And so here's what I want to distinguish early on about Software 2.0 versus, let's say, vibe coding. A lot of the emphasis around AI coding has been around one-shotting an app, where you just give it a prompt and it's able to assemble a working application without very much involvement from you at all. I was I was camping this weekend, and I was sitting on a porch of a cabin, smoking a cigar, drinking a little bit of whiskey, and I asked my AI agent that I've been working on to one-shot a snake game for me that used swiping to go ahead and work. And it was able to do that and use my Tailscale network to go ahead and do Tailscale serve and make it available so I could play it. And it did that in the span of about 20 minutes, me just sitting there. Okay. That is not software. That's cool, but that's not Software 2.0.
Yeah, it's been done before.
It's been done before. Yes, exactly. Snake is something the agent inherently understands because there's probably 1,000 other snake games out there on GitHub or whatever, and it's a very simple application. If you wanted to build a brand new application done your way with your tastes and with all the little details you personally care about, can't vibe code that very easily because you're going to have to be drawn into a process where you're spending a lot of time defining in text what it is you're going to create and what some of the constraints are around it. And this is essentially, product requirements documents are one part of it, but it's also doing things like UI mockups and workflows and all the bits that go into creating a brand new piece of software from scratch. And so what Software 2.0 is about is the role reversal that software engineers are going to go through if they start working with large language models to code this. Rather than having an idea and just sitting down and opening up, Visual Studio or whatever your preferred tool is and typing out code, what you're doing now is you're firing up Claude or the Copilot CLI or whatever your preferred tool is there, and essentially just writing specification documents and outlining implementation plans and then refining those and then trying to get it to give you mock-ups and approving that. And essentially you're sitting back and are pairing with like the world's fastest junior developer who can sling out reams of mock-ups and diagrams. And then, you get all that sort of like planning stuff done. And then there's the implementation phase. And the bulk of that work isn't you coding anymore. It's verification. It's making sure that what the agent built matches your specification. And the more you can automate that using deterministic methods, the compiler being the best one, that's like probably the most deterministic method. But the more you can basically work on verification where you don't have to trust the LLM's output, you can actually concretely verify it, the cheaper that becomes and the more scalable this process becomes as well. And that's really the direction I'm kind of taking these Software 2.0 essays in. There's going to be more of them. And the thrust of it is that Software 1.0 is about specification, developers specifying behavior through code. Software 2.0 is about verification. You are going to be spending your time building verification systems, and the LLM is going to infer what it needs to do to try to satisfy those. Now, go ahead. Sorry.
Verification systems, you mentioned compiler. You haven't said tests yet, but what are your go-to short list of verifications that you kind of know are going to be in there somewhere?
So probably automated testing's got to be number 2 after the compiler. The tricky part with automated testing is if the LLM's authoring them.
Mm-hmm.
Because you can end up with what I usually see, and like we saw this with TextForge, you end up with some really anemic tests that don't test very much. So they're very literal. A thing that I mentioned in the first Software 2.0 essay is how alien the reasoning is that large language models use. They're not thinking about this in terms of, let's say, a human developer, where my goal is to use the minimal amount of test code to validate all these different scenarios that might occur inside my application. They're thinking, I need to literally prove that this string formatting function that I just did, formats the string correctly. And you end up with these super low value kind of, anemic tests. So that's, one of the ways you can kind of work against some of that is scaling up the test suite initially to do more things like integration tests. This is where I've mentioned it briefly in the Software 2.0 stuff, but I haven't gone into detail on it yet. .NET Aspire has been really useful for doing this, being able to orchestrate the entire sandbox the application runs in.
Mm-hmm.
I've even got a formula that I codified into a skill for being able to use .NET Aspire with an open source project called MailPit, where it fires up an SMTP receiver, and you can basically see all the outbound transactional emails the application's producing. So if you want to have your LLM verify that it sent the correctly formatted receipt to a customer, you can actually do that pretty achievably through something like Aspire and MailPit. So learning how to try to build some automations where the LLM can go and touch the different parts of the application and verify they're working is super useful. Click testing has been another thing that I've had to do, where this is, for a very good reason, you do not want to write these as like automated, 100% done consistently every time sort of tests. Mm-hmm. And the reason is that UI tests with something like Playwright are extremely fragile. And the LLM will waste a lot of resources trying to constantly adjust those every time you start tweaking your layout or moving elements around on page. You kind of don't want to do that. Instead, you want to leverage the LLM in a little bit more of a fuzzier way, where it's like, okay, I want you to screenshot walk the entire sign-up flow from beginning to end, and then all those screenshots need to be present when I have another agent do an adversarial review after you've done your work. And if those screenshots are missing, basically the whole automated coding thing bails out and waits for me at that point, where it says, okay, you did not produce the evidence you needed to. Either there's something wrong with the prompt or there's something wrong with the infrastructure, and we're going to defer back to human judgment on that stuff. And this is sort of where you get into the really cool part, which is unattended automated coding, where you're having the LLM write code while you're asleep, for instance. Mm-hmm. Other types of verification, I use this example in one of the posts. I have a link validator library I wrote that does brute force sort of scanning to check for 404s, and I could also probably enhance it to look for missing images as well. But you can use that to make sure that, is this thing hallucinating like internal links or links to external partners or whatever, and brute force that out of the system. That'd be another good example. And then you can start getting into much crazier stuff like formal verification, where you have like lemma solvers doing theorems and all that. I haven't gotten there. That's too academic and computer sciencey even for me, But if I was using Claude to vibe code a distributed database, maybe I'd probably invest more in that,
Yeah.
But that's sort of go ahead.
You mentioned your mail, your SMTP mail sender, which in any kind of testing, once you get to a boundary that calls out to an external system that you really don't control, you got to stub it somehow. You have to put in a stand-in implementation for testing. And what struck me is that you said, you know what? I'm not going to code a stand-in implementation of send me an email because it's going to be completely fabricated. But you found an actual real implementation of something that can send using SMTP. Oh, but just drop the emails in a folder instead of actually send them across a network somewhere that I don't control. So that all the assumptions about, well, what is necessary in order for any SMTP implementation to actually work, you actually have that as part of the verification.
Yes. The closer you can get to the final, the closer you can bring the LLM to the final output, the better results you're going to get. One of the libraries in .NET, in particular, that I really like to leverage for this is the Verify library that Simon Kropp wrote. It's a snapshot testing tool. So for instance, going back to this email example, we use, I think, the MJML.NET library to go ahead and do, that's what actually synthesizes like our transactional emails. I have a tool that can basically take the MJML output and then render it to HTML. And then we're kind of showing what like the rendered email output will look like when it's actually sent. And I'll stick that into a verify call, which will go ahead and verify the output. That way, if the LLM is moving walls around or whatever and restructuring stuff and it breaks all those email templates, all that stuff just pops off real quickly. And the LLMs are pretty good at, for the most part, at self-correcting and trying to reel themselves back in and not break those externalities. But sometimes they still do. They'll decide, I'll just disable that test. Whatever. We probably don't need it. And I wrote a little program that I haven't done a blog post on this yet, but I wrote a little program called SlopWatch for .NET that basically you can run it in CI/CD or you can run it as like a Claude Code hook. I've had very mixed results using it as a Claude Code hook. Instead, I kind of bake it directly into the prompt itself, where it can detect what's called reward hacking behavior from LLMs. This is where they're following your directions literally, but not to the spirit of the law, Get the entire test suite to turn green. Great, I'll just turn all the tests off.
Yeah.
And that'll work. And this is designed to try to catch some detectable versions of that. So disabling tests, suppressing warnings, and it can catch you if you're trying to suppress warnings via MS Build magic as well. The tool can detect that. And I think I've got empty catch blocks where you're suppressing an exception. SlopWatch will flag that as well. So it's pretty opinionated because it has to be, right?
Yeah.
These are common things LLMs will do to be, and reward hacking. I won't get into the all the ins and outs of that, but the basic gist of this is that LLMs are rewarded by successfully completing objectives, and it's going to try to do that. And if it runs into friction, it might not always choose the most appropriate path to solve a problem. It might hack its way around it, and you need to combat that somehow. So that SlopWatch tool is a pretty brute force way of doing it, but man, it catches issues every day when I use it.
Well, we'll include that in the show notes. So you said SlopWatch. The one before it, the Verify library. What was the full name of the Verify library?
I think it's just called Verify. Let me find it.
Okay. And the author again, Simon
Kropp. Yeah, it's just called Verify. It's got about 35 million downloads.
Yeah, we'll include that. And you mentioned the LLMs are pretty good at. Now, which LLMs are you thinking about when you make that statement? Which LLMs do you even spend time using versus all the others where you don't even bother?
So I am running a mix of three right now. I have a Claude Code Max subscription, and my goals, I have the 20x version of it, and my goal is to get to 100% utilization every week if I can. I've had a couple weeks where I use Opus and Sonnet are the two that I use, 4.6. I have not needed as much. I've probably hit that subscription to maybe 50% utilization for the past few weeks in a row. But like when I was launching TextForge, I was definitely hitting 100% every week on it. A lot to do. A lot of that was just the last 20% of delivering a piece of software, like debugging our Stripe integration, took a ton of work. We had an onboarding system that tries to get the user to complete like 3 or 4 steps, and all of the different like little UI sync issues there. It took a lot of manual Q&A with me. That's another thing that is a little different about Software 2.0. I spent a lot more time click testing the UI myself and trying to test things. I was able to have the LLM do the lion's share of that, but things like running a fake credit card through Stripe and testing to see that the checkout experience all worked correctly, and then doing things like downgrading from one plan and then canceling and then reactivating again, all that sort of fuzzing stuff. I wanted to make sure that that all worked out of the gate so I wouldn't have an emergency after we launched. All that took a fair bit of time, maybe a few days. worth of pretty intense work to do it. I'd find 4 or 5 bugs each time I do it, file a GitHub issue for each, and then have Claude work in parallel across a bunch of different work trees to fix them. If I could parallelize them, sometimes I had to run them in sequence because one issue affects another. But usually they were discrete. Get them all fixed, do a new build, and then retest it. So I use Opus and Sonnet pretty heavily, and then I also use the Codex models pretty heavily. I do not use the Codex CLI at all because I found that it's pretty far behind what I'm used to using with Claude Code. But the Codex subscription works great with OpenCode, which is another coding harness. So I use both my Copilot subscription and my Codex subscription with OpenCode. And I have a script I wrote that synchronizes all of my Claude Code settings essentially with OpenCode, so I can shift gears between them no problem anytime I want. The Codex 5.3 model I use pretty heavily. That if I want to do deep debugging on like a pretty massive pull request, I'll fire up and GitHub Copilot because Copilot bills per request, not per token like everyone else does. I'll fire up my Copilot subscription, point it at a pull request, and I've got a standard prompt I use telling it to look for errors, bugs, anemic code, anything that deviates from our documented standards of skills, blah, blah, blah. And that thing will run for 90 minutes going through all of it. The one big difference, though, is that those Codex models on Copilot have a much smaller context window than they do when you just run them on OpenAI. That is a noticeable difference there. But otherwise, that's a pretty effective cheat for being able to get detailed results done. So I feel like the Codex models, just in terms of their ingrained biases, are much more plotting and slow and detail-oriented, which is great for an adversarial reviewer, which is what you want for those. So I'll use them. And then locally, I bought 2 different AMD GPUs with 32 gigs of VRAM each, and I'm running a bunch of Qwen models, Qwen 3.5 locally with that.
Llama?
I'm using llama.cpp right now because Ollama has a little bit of don't want to get too deep into the weeds on here, but basically the support for AMD stack is a little bit more mature outside of Ollama. The other problem I have is that Ollama wants to run one model split across both GPUs. And because I've got because I have like a PCI 3 motherboard on there, that absolutely kills your inference speed big time. It just takes aeons for anything to get processed. So I'm running 2 different Llama server instances with a reverse proxy in front of them.
Okay, so you're not using Ollama, but you're using Llama CPP. What exactly does that look like? Is it just a command line harness instead of installing the Ollama client?
It's a much more do-it-yourself sort of vibe. Like I can't easily switch between models on my cards. I've got to update like a systemd config file, all this other stuff in order to get that to work. But the inference is a little bit faster. I'm able to pre-allocate my entire KV cache. So once I have that up, and because those Qwen models, by the way, support like just over $250,000 tokens as far as their KV cache goes. So even though they're fairly small models, I'm using the 27 billion parameter one. Even though they're fairly small models, they are punched way above their weight class in terms of their context window size you can get out of them.
So would you say that for people who only have one GPU on their motherboard, that the Ollama client would be just fine?
Yes. Yeah. Okay. Fine.
All right,
my issue was the PCI. Essentially, with like NVIDIA GPUs, you have NVLink, and you can link those together and get pretty good interchange speeds. AMD doesn't have an equivalent to that right now, so you're kind of limited by how fast your motherboard is, and that's not great in my case. I've got a 5-year-old motherboard on this computer.
So you're finding that 32 gigs of VRAM makes a huge difference for being able to load a model of that size and doing useful things with it.
Yep. It means that I can use a fairly it's not totally unquantized, because the unquantized version of like the 27 billion parameter model is still like 60 to 70 gigs, so I can't use the unquantized versions. I think I'm using one of the 4-bit quantizations on there, and they vary a little bit depending on which sort of file you pull down. But it's been able to keep attention for a pretty long period of time, which is good. I can have it's very good at tool calling, which I care about a great deal. And it's able to basically maintain a fairly non-lossy conversation over the whole length of the conversation. The 27 billion parameter Qwen 3 model is super dense. Every single parameter gets activated for every token. So it's using a lot of horsepower to try to answer your queries. If you compare that to like the mixture of experts model, like the 35 billion parameter one, that's only got 3 billion parameters that are active. So you're going to get much faster response times, but it's going to have like amnesia the longer the conversation goes.
Okay.
So I've been using the 27 billion parameter model because for most of what I'm using that agent for, it's background type work, where I'm not sitting here waiting for it to return code to me. I'm using it to do things like this morning, we're looking at changing our email marketing system, and I was having it build a comparison matrix for me, where it's mostly just doing an internet search, collating research together, and then sticking that in Notion, And that Qwen 27 billion parameter model had no trouble doing that.
Nice. Is that, from a speed perspective, is it something where you give it a half day and come back? You give it a half an hour and come back? What's the general?
I get up and go make a cup of coffee, and it's usually done by then.
Okay.
So it's more like on the order of minutes.
Okay.
Yeah.
Got it. So pretty darn fast still. Nice.
Still pretty fast. It's probably got to be doing 70 or 80 tokens per second. It's just that I'm messaging it through Slack, so I don't see all the intermediate output.
Right.
Yeah.
Okay. Nice.
So I basically message it, go up, do my thing, come back, and then it'll send me some little update messages if it's doing things. Like if it's in the middle of a long tool call chain, it'll go ahead and let me know, hey, I found some good literature about blah, 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 just kind of letting me know it hasn't died. But it won't deliver the final result until it's got everything it needs. So yeah.
Right. Nice.
Yep.
It
this
seems
is my
like there's
NetClaw project I was telling you about before we started. I'm running this on.
Nice. It seems like there's a renaissance in remoting, like dev tunnels or connecting with Slack, or just what are all the ways that I can not be in front of my big computer, but at the same time access and have something running on my big computer.
Oh yeah, I've got so myself and a couple other .NET developers have all been discovering how great Tmux is on like Linux boxes, which is these like remotely hosted. Well, let me rephrase. It's basically like a persistent bash session on a Linux server, and you give it a name, and you can basically you can connect to it from multiple machines and sync on it. So the way I do most of my Claude code and open code work these days is I've got a virtual machine running on the most powerful server in our office, and I basically just launch into it either from my Windows machine with WSL or from any of my Linux computers at home, and I have a command I can run that'll just open all of my Tmux tabs and basically spawn a bunch of command windows, and I can go ahead and just stay synced with whatever's going on from wherever I happen to be at any point in time. That also lets me do things like kick off a long-running Claude code session in the background and then drive to the office and pick it back up when I get here. So it's working during my commute and so forth. So
nice.
All asynchronous, all of that stuff.
So we'll include that in the show notes, spelled TMUX, or terminal multiplexer. Nice. Well, I want to get back to your Software 2.0 blog post on aaronstannard.com. And one of the things that you talk about extensively in here is not just fire and forgetting the AI tool, but doing a planning process. So how did you figure that out, and how did you figure the sweet spot between this massive big design up front and just enough design so that it's effective?
That's such a good nuanced question. Actually, it's like you don't want to have it design a Taj Mahal with you, day one, right? That's always been a terrible way to design software. I don't care what the IBM people from the 1960s say. It's not a good way to design software. This is especially true if your requirements are going to change as the further you get along in the process. Like if you're in a big corporate environment and you say, hey, I might have a idea for being able to improve our, business process for doing X, Y, or Z. colleagues might be a little skeptical. And then as you get further down the road, and if they see results, they'll say, great, can you also get it to do X, So you kind of want to like have checkpoints along the way where you want to get from A to B and then start a new planning session to get a little further from there. So the where I kind of discovered planning with LLMs was my real introduction to LLM coding for real, like beyond autocomplete, was probably when I started using Cursor at the beginning of last year. I used Cursor, but I don't use it so much anymore. I basically don't really keep an IDE open when I'm programming very much anymore. Sometimes I do, but generally I don't. And where I really kind of found the sweet spot on that is when you start a project, or really, let's say you want to bring AI into a project where it hasn't been used before, the first thing you want to do is kind of define a constitution. What is this project about? What are its business goals? What are some of the key constraints it operates under? And man, people forget that one, the key constraints part all the time. So like, okay, this software is constrained to being deployed in a Docker container on a budget Kubernetes cluster because this is not the main fixture of our company. It's gonna have access to fairly limited resources, and we don't need to go crazy. It's not an embedded system, but we're not going to be running on a 64-core GPU with the quarter terabyte of RAM. That's not going to be the case. So you want to kind of specify that in your constitution, and you might want to have some sort of routing documents in there that kind of explain, if we are working on UI and design, you're going to look for files in this folder. This is where our mockups are, and where things like our branding guidelines and our color guidelines go. That all goes there. If you're looking for engineering specifications, you might find them here. And if we're working on core product literature about like the product requirements documents and basically like what the user stories are going to look like, you might find those here and have some of that routing in place. So you're kind of building a structure to repeatedly evolve the project. I'm going to write a bit more about that in some detail a little further on in the Software 2.0 series. But after you do that, you actually got to start building something. I think it's always best to start with a template, personally, when you're working with AI. So that way you take a ton of guesswork out of it. So I've got a build template that we use for all of our Akka.NET open source stuff that I just use as my starting place. It uses the central package management and NuGet. It has a global.json. It's got GitHub Actions or Azure DevOps built into it. Has a lot of like just good baseline stuff you'd want to have from day one. So get all that pulled in. That eliminates a bunch of decisions the AI doesn't even need to make, like how do I use CI/CD? That's just built into it. And then from there, you usually begin with a kind of a long planning session in planning mode in whatever your preferred agent harness is. So Cursor added one, I think either just before I started using it or maybe just after I started using it.
Yep.
And that was a huge breakthrough for me because I didn't like it when I felt like I was having to tug on the agent's reins all the time to get it to stop doing stuff that I hadn't explicitly told it to do. So getting a little bit of clarity on what it is we're planning on building together, even though I know the agent's understanding of that is very different from mine because of the alien reasoning I mentioned earlier. Getting it to actually talk back to me and kind of echo, here's what we're planning on doing and why, and here's the initial sets of things we need to do before we begin coding. So for building a web application, step one is almost always defining your key users and doing workflows. What are they going to try to achieve through this application, and what does that progression look like? After you get that down, next most important thing you could do, because it's also a very useful verification tool when you're doing this sort of automated verification pipeline, is mockups. Go ahead and basically get some full-blown HTML clickable mockups built from scratch. Now, if you've got Figma or other tools like that, if you have someone on your team who's a real graphic designer, you should use that stuff instead. But for me, since I'm just kind of doing things by the seat of my pants here, I'll go ahead and have it produce some clickable mockups, and I'll have it give me an array of choices, kind of like a swatch, if you will, of different styles and colors, and I'll pick one that I like and maybe say, I like this one the most, but I want you to bring in these elements from mockup B and C. And then we'll keep iterating on it until it looks good. Then I'll say, okay, great. I want you to extract a brand guideline from this and go ahead and help me work on getting the colors, fonts, and all that figured out. Then we'll do that. Okay, great. What are the other screens we need to build this first workflow? And We'll go and list them, say, okay, let's do a little mock-up for each of those too. That all gets baked in. And then we'll shift gears, talk a bit about the implementation stack of, okay, what technology do we want to use for this and why? So for TextForge, we're going to do a whole bunch of asynchronous background processing. Akka.net's a really good fit for that, So go ahead and slot that in. And then we'll say for the UI layer, I've got this template that uses Blazor Server for doing all this stuff. Most of the way people interact with this application is going to be via either its HTTP API or MCP, or via the Slack and Discord and Teams notifications we send, letting people know an email's available. Okay, well, in that case, then I guess we should just build something that's relatively inexpensive and looks nice, and it has the ability to do live updates and refreshes. We'll use Blazor for that. And then we might also go ahead and introduce a couple of other guardrails before you begin coding. Like I'll define some code standards. So like, for instance, when you're working with Akka.net, all messages need to be immutable. You should use record types for that.
Yeah.
When we're working with SQL, we prefer Dapper and parameterized SQL queries over EF Core or whatever the case may be.
Sure.
Lay all that out. And then after you've got all that information, you got some PRDs going, you've got your mockups, you've got your implementation plan. The final thing you do before you can really take the LLM off a leash and have it start vibe coding, or not vibe coding, but coding all this stuff automatically, is you have to go and put together an implementation plan in a form where an LLM can achieve a measurable goal in a single context window each time. And it has to include instructions on how to verify that it achieved that result. And this is sort of where those techniques like Ralph come into the picture, the Ralph loop, where you have an LLM essentially getting invoked in a loop inside Bash, more or less, is what that is. Or PowerShell could also work. The trick for that is you have to have an implementation plan file that basically kind of gives the LLM access to all the resources it needs. All the tasks need to be scoped appropriately small. And then every n number of iterations, you kind of want the process to stop. And you want to have someone do an adversarial review of everything that's been built. Because if you let the thing run for too long unchecked, you're going to get some really weird looking results eventually. And so I will usually have the LLM do an adversarial review on its own work. And it's given instructions to be brutally harsh, be as harsh as possible. And essentially it'll start rearranging the implementation plan based off bugs it finds. So we found a security vulnerability in the way we're handling secrets here, or we found this agent wasn't taking screenshots at all when it was doing all this UI work. And some of the other kind of interesting things the LLM could do, if you let it, is it can actually start updating its own constitution. If you give it permission to do that, saying, when you do UI work, you must always do a screenshot here. And then, let's say an LLM runs into an issue with Playwright where it can't do that. The adversarial reviewer might find that issue and then add a new workaround for that to the constitution. If you run into this Playwright error, please use this skill to figure. And it's kind of like it'll start gradually self-improving a little bit if you let that happen.
Yeah.
And that's where the really cool sort of like the self-improving feedback loop stuff is like probably the highest. That and maybe doing like swarms of agents working together is like the sort of advanced frontier of LLM coding right now. I'll stop there and see if you have any questions.
Yeah, sure. Well, one final question. I feel like we could do like a part 2 and 3 and 4 and 10, but I gotta imagine that you've got Akka.net implemented around here because I'm thinking, an agent. Wait a minute, an actor. Little things running around doing. So, in your world, what are you finding that using an Akka actor to be kind of like the chief overseeing one of these AI processes, where does that fit in real nicely?
So people should be using people at like OpenAI are discovering this now. They're using like Erlang to build actor orchestration tools, which is Erlang is like the OG actor model implementation. Actors are agents and agents are actors. And I'm using Akka.net right now in a new project that I've been teasing it on Twitter, but I haven't open sourced it yet, called NetClaw. Not a very imaginative name, but it accurately describes the project. This is an OpenClaw-inspired autonomous agent. This is what I'm using all the Quen models for right now. And my goal with NetClaw was pretty straightforward. I don't want this to basically be a Claude replacement because Claude Code is great and works fine, or an open code replacement. What I want is something to help automate the ocean of interruption-driven stuff that happens in my life as a business owner. A new GitHub issue gets filed, a new email gets received, a new form gets filled out on our website, a support ticket comes in, yada, and then lots of clock-driven stuff I have to do every month as well. There's lots and lots of toil in our businesses that I want to be able to automate away. And what this requires is a little different than something like a Claude Code or an open code. It's more like what openclaw sought to achieve, which is a persistent, always-on agent that's listening and reachable via communication channels. But openclaw's got some deficiencies that I wasn't happy about when I was using it. I thought it was kind of jank, the whole code base. I thought its permissions model was non-existent. They've since realized that and are frantically working on patching that for good reason. It's produced some pretty hilarious accidents. Mm-hmm. And I also thought that the lack of MCP support was a really fatal mistake for that project. There's been this controversy around should you have agents call CLI tools or call MCP? And the answer is MCP is going to be the way stuff is done because you're not going to get Marjorie from accounting to install the Google Cloud CLI and create a service principal and like that.
Right. And authorize it and all that.
Yeah. Yeah. It ain't happening, man.
That's why web services exist.
Exactly, right? MCP is basically a way for LLMs to use OAuth to call web services. That is what it is. The arguments about them being token inefficient, by the way, completely solved problem. That's like just NetClaw has this built into it. It's called dynamic tool loading. You only load the MCP tool definitions when they're needed. And you can infer that the same way an LLM infers everything else it does. So that's a solved problem. MCP is the way to go, and I think it basically probably should be treated like a first-class citizen. So basically I'm using Akka.NET to run all of the different LLM-facing parts, actually LLM and streaming-facing parts of that system. So it runs the bridge between Slack, Discord, or any other real-time communication channel and the LLMs. The LLM itself is basically called a LLM session actor that keeps track of its ongoing conversation and it persists that to a SQLite database, so it's reentrant. Keeps track of basically automatic memory formation when it's going. So we have certain checkpoints that kick in at different parts during a session, like compaction is one of them. But there's other checkpoints that happen much earlier than that, where we basically take a look at the conversation so far and decide, is there anything that represents a durable fact that is worth saving in this case? So use the example before the show. I used NetClaw to help me book a flight to a conference I'm speaking at later in the spring here. And I had to mention, I fly out of IIH here in Houston, and I'm a United Airlines Mileage Plus member. It remembered all that information when I just asked it, maybe a few days later, hey, can you help me book a flight to Boston in October? It recalled all of that without me having to tell it to do it. Nice. And it's kind of getting memory right on an agent is a little tricky, because you don't want it to remember creepy stuff and start like introducing nonsense into there, but you also don't want it to be a goldfish either. So there's quite a bit of a balancing act around that. So that's one thing. The other is having a good security disposition is something that I've been working on with NetClaw. Specifically, I'm imagining that down the road, if you wanted to actually make enterprise agents a for real thing and not just a throwaway line at a Microsoft Build conference that no one mentions again ever a year later, you've got to have something that can eventually map to a real identity system like Entra. And that's something that, like, for NetClaw, no self-respecting developer is going to set up their own Entra account to run a little chat bot that's talking to them on Discord. So the initial version of it we have is basically more of a simple policy document, kind of similar to like a Tailscale ACL file. That's kind of what that looks like. But if you wanted to make something like NetClaw accessible for doing real enterprise work, you would give it like a service account or a managed identity, an Entra ID, and that would help it define what level of access it has to various resources inside your network. If you wanted to have a bot that could basically pull information down from application insights and do incident analysis, that'd be like a really canonically useful and good example for deploying a bot like that. That would be something it could do. Even better, it could do it automatically as an incident happens rather than being told what to do, that's kind of the direction I'm trying to take it in.
Nice.
Yeah.
Well, we could go on. This is fascinating stuff. There's so much to talk about. So much is changing in the world. But kind of as we close here, you mentioned a conference. Where can people find you next?
I'm going to be speaking on, I think it's May 1st at Stir Trek in Ohio. That's in Columbus, Ohio. That should be a good one. And then next confirmed conference I'm going to be at is NDC Copenhagen. I think that is in June. I don't have the exact date in front of me, but I'll be speaking there. I've applied to speak at some other conferences that are happening later this year. I have no idea which ones I'll get into, but hopefully some more.
Awesome. Well, thanks for coming back on the AI DevOps podcast. This is a great discussion. I appreciate it, Aaron.
No, thanks for having me. Hope you and your audience both find it interesting.
Absolutely. No doubt. Thanks so much. And until next time, dear listener, keep shipping.
You've been listening to the AI DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.